Welcome to this video on how to create bracket transfer media, and in this video we will focus on how to make your transfer media with non-biocompatible materials. So what is bracket transfer media? In the FreeShape Auto software, in the bracket placement module, you can place brackets on the teeth, but you need a way to get them into the patient's mouth, and this is what we will cover in this video. The approach will make it possible for you to place the brackets more accurately in the patient's mouth with a shorter seating time, and it will also be possible to delegate to assistants in the countries where that is legal. There's a high degree of flexibility when it comes to making the transfer media. So in this video we'll be covering the markers approach and the containers approach, and I'll go into details what that means. But when it comes to directly printed transfer trays where short-term biocompatible materials are needed, we will cover that in a different video. So what will you learn in this video? How to make the markers and containers master models for vacuum pressing. We will also learn what the different production parameters do and what you need to do when it comes to tweaking your designs to accommodate various production machinery and material issues that you might encounter. And also how you export your design for production on your equipment. So what is a marker model? A marker model is a model that will be printed where you can insert the actual physical brackets into the holes in the model, and that will then allow you to vacuum press on top of that model. It has the distinct advantage that are very, very low accuracy requirements for the printer, meaning that you can actually print this on pretty much every printer known to man that is relevant for the auto space. The brackets are embedded into the tray, and that requires the hooks and wings of the brackets to be protected by silicone. So when you remove the transfer tray afterwards, you will not debond the brackets. So this is the standard procedure that is also used when you make analog directly printed, analog indirect bonding transfer trays. In this approach, it's not possible to lift the bracket base from the tooth surface if you want to change the inclination or otherwise. The other approach we will cover in the video is what we call a container model. And here the idea is, as you can see in the purple model in the lower right, that a bracket representation is added to the model where all the undercuts are removed. As with the markers, this will create a model where you will then vacuum press on top of it. But it has the advantage that you don't have to protect the hooks and wings with silicone, so it's a bit more time efficient, and then you will click the brackets into that transfer tray. In this approach, you can actually angle the bracket base away from the tooth surface to create a different inclination or whatever you want to achieve if you have placed the brackets in a different angle inside the bracket placement software. This approach is also possible to do on printers without the highest accuracy. So this is also very, very much relevant for printers that maybe don't have access to materials that are not short-term biocompatible. But let's dive into the software and see how this is made. I will be showing this in a software version, in an upcoming software version, so the UI might be a little bit different, but all the steps are identical. But first you will left click on the model with the green outlines, and then go down here and choose Create Bracket Transfer Master Model. Then you click on that, and you can see it has already then pre-chosen the model you want to do it on. You could change the color, but this seems good, so we'll press OK. And then here under markers are the various options we can tweak. I'll make a version for us to evaluate while we discuss the various production parameters. So now here the software is done. I will turn off the original model, so it's a bit easier to see what goes on. So here you can see the software has now created these walls where you can then insert the physical brackets. So you will then print these. The various production parameters in the software are used to handle various aspects that you can encounter during production, where you want to tweak the output so you will have a more desirable result. The first parameter is this inner surface offset, and that will on purpose make the hole for the bracket too big or too small. So we could adjust it to minus, and then it would make it smaller to have more friction and grip around the bracket, or we could make it bigger if we had some friction issues. So let's try making with a little bit bigger offset so we can see how it will actually then make more room for the bracket. And here you can see that the value of 0.1 millimeter is then added on each side of the bracket. So if we had friction issues or maybe a printer that was a little bit out of alignment, then parameters like that would be able to make sure that you can still insert the bracket into these markers. The other two parameters control the width of the walls and the height. So let's say we have a very low profile bracket where we wanted to reduce the height of the walls. Then we can turn them down all the way to 0.2 if we wanted, and then we can see how that will now affect the height. And there you have it. Now the walls are only 0.2 millimeter, and we could do something similar with the width. So this is how you can create the various sizing and other issues that can mitigate various problems you might have when you actually insert the real brackets. The last four options here are only relevant in the upcoming 2017 version of the software, and here we can decide on which sides of the brackets that we want the holes to, where the flash will be pushed out. So if I only enable the incisor ledge and recalculate, then you will see now that the holes will only be on one side where we have chosen that it should be. And there we go. Only hole in one area, so now you only have to clean up the flash in this area. In this next section, we will dive into how it is possible to make the container model. And here the idea is that we will create a version of the model where there's a bracket representation in place of each bracket. Then the idea is that you vacuum press on top of this and then insert the brackets into the transfer media that you will vacuum press on top of this printed model. It has some advantages compared to the markers. First of all, you don't have to protect the hooks and wings with silicone, because as you can see here, the software is able to automatically remove all the undercuts of the individual brackets, so you can insert them freely into the transfer tray afterwards. And the same also with the wings. So this is a very effective way to save some time regarding the silicone. There are again some production parameters that will help you accommodate various issues that you might encounter once you print that and want to insert the brackets that could either increase the grip or mitigate other problems you might see. So let's go over all the parameters. The first one is the inner surface offset, and that one will on purpose make either the bracket representation too big or too small. So that is mainly seen as a way to accommodate a general friction issue. The tooth surface itself will remain same size, but the bracket representation will be too big. So it's mainly seen as a value where you might want to make it a little bit smaller if you cannot insert the brackets, or if your machine is out of alignment, then you can make it a little bit bigger. The next one is called the block out angle, and that will actually make these undercut removals at a certain angle also to accommodate friction issues. So if we raise the value here to, let's say, 10 degrees and then recalculate, then you'll be able to see that the wall here is going to be at a tilted angle. And here we have it. Now you can see that the walls are tapered with a 10-degree angle, so it will be a conical hole that you can insert the bracket into when you have made your vacuum pressing on top of this model. Okay, we have now removed the blockout angles again, and now we're ready to demonstrate the next setting, and that is the retention amount. The idea behind the retention amount is that you can see here that all the undercuts are removed, as we have previously discussed. But if we add a retention amount, then part of those undercuts will be reintroduced. So let's try to set it to 0.1 millimeter and see what happens. Here we go. Here we can see that the part of the undercuts have now been reintroduced according to this retention amount that we have now put on. So when we do a vacuum pressing session on top of this, then the hole that will come where the vacuum pressing plate will now follow this model will sort of enable the bracket to click into space. The final parameter is this prolongation length. That takes care of any artificial hole that would be underneath the bracket base and the tube surface. Holes inside 3D objects are very bad for printing, so this parameter artificially prolongs the bracket base into the tube surface. If you have a case where there's very thin incisors and the bracket is maybe placed close to that thin incisal edge, then you might need to lower the prolongation length, but we have not yet seen a case where the 1 millimeter isn't the right setting for this. But now you at least know what it can do if you encounter a case where you will see the bracket base sort of protrude through the tooth here. With all of these tools in mind, we can now very briefly touch upon what would you need to adjust if you encounter a given problem. I would recommend starting with the standard values out of the box here. But if you experience problems, then you have some options here to mitigate that. So let's say that you have problems inserting the brackets into the vacuum pressed tray. For that, I would increase the inner surface offset to make these bracket representation a little bit bigger. So when you do your suck down on top of these, then the hole for the bracket will also correspondingly be bigger. So there's no sort of value we can just give you now that would be the right one. That will have to be a little bit experimental depending on exactly how your printer is fine-tuned and also the material properties of the material that you have loaded into the printer. But start with the standard setting and work your way up from there. The other problem could be that the brackets might snap out too easily. Instead of lowering the inner surface offset, where you will make the tray fit tighter all around the bracket, there instead I will actually recommend you to add the retention value that you saw before to create these edges. That would make sure that the hooks and wings can be inserted all the way into the transfer tray, but it will then grip around these tiny indentations here. So that would be my go-to for a value to adjust if you have problems with the bracket slipping out on their own. Once you have fine-tuned these values, then the next thing is which vacuum pressing sheets should you apply for this. And there I would recommend you to go with the sheets that either your reseller for these vacuum pressing sheets recommends for you for indirect bonding. These sheets has been made and used with big success all over the world for analog indirect bonding, and I would recommend you to go with whatever you prefer there, so you know how the materials are to work with and what works best for you. FreeShape don't manufacture neither vacuum pressing machines nor the materials to load into them, so I will have a hard time recommending something specific for your given machine. So talk with your reseller of the vacuum pressing machine and or the sheets that you load into them and hear what they recommend for indirect bonding. You're of course always welcome to send your favorite settings back to FreeShape, and then maybe we can try to find a way to share them with some of your colleagues around the world, so we can have some knowledge sharing based on this. But several teams around the world are using this with great success already, so we really hope that you'll be able to benefit from this video and get started with the indirect bonding transfer trays for non-biocompatible materials. Thank you so much for listening.